Right, standard 8.2 is just talking about the real number system. So natural, whole, integer, rational, irrational, and real numbers. Describing those is 8.2. There's two different ways they like to ask these questions. One is pick the best word, and the second is pick all of the words. So sometimes you have to pick everything that describes it, meaning like the number 4, that's a natural number, that's the best word to describe it, but it's also an integer, it's a whole number, it's rational, so those would be all of the words that describe it. So in this first one, we're just looking to pick the best word to describe that number. It's just looking for one word. Basically, in this kind of a diagram, when we had this, when we had the natural numbers, the whole numbers, integers, rational, and then irrational, which is completely separate from that. When we had that diagram, what group would that fit into? Okay? That's basically what this is asking. What's the smallest group that we can squeeze that into? When we have a square root, we don't want to just leave it like that. We actually want to take the square root of that number. We want to figure out what that is as a decimal. That is 2.449 going on forever. That goes on forever, doesn't repeat itself. It's a decimal that doesn't stop, it doesn't terminate, and it doesn't repeat. That's an irrational number. If we wanted to say that all of the words that describe that, the only other word that we can add to that is real. Irrational numbers can't be any of those other 4. They can only be real numbers, and actually all of these are real numbers. All right, on our next one, we have a decimal place, so we want to look at that carefully, but that's a 0.0. This is really the same exact thing, it's just -4. So there really is no decimal place. It's a negative number, so it can't be natural and it can't be whole. It has to be an integer. It's not a decimal, so we know it's not rational. That's not the best word to describe it. It is rational, but that's not the best word. It's really an integer because it's a negative whole number. Next one, same kind of thing. We want to make sure that we're not looking at that as 75. We need to change that into a decimal. That's really 0.75 as a decimal. That's a decimal that stops, comes to an end at some point. That is a rational number. Any fraction that doesn't involve pi is also rational, so that's what we're dealing with on number 4. You could divide that out and get 1.5, and you see that it's a decimal that stops. Or you can think about any fraction that does not involve pi. That is going to be a rational number. I like looking at it as a decimal to just make sure if that decimal stops or it repeats, you know it's rational. Okay? This next number, again, we want to figure out what that is as a decimal, so we're going to get rid of the scientific notation part of this. That's moving the decimal place 4 places that way. It's going to give us 3 zeros. That's really 15,000. It's a big one, but it's still one of our counting numbers. You'd eventually count to that. That's a natural number. Last one, I see pi, immediately I know it's irrational. I don't really even care what they're doing with it. I know that pi divided by 5 is still going to be a non-repeating, non-terminating decimal. Alright, so that's just picking the best word. Now we're going to pick all of the words. That's still really using this diagram up here. But now we want to think about if it's in a small group. Let's say it's in the natural numbers. Different color. Let's say it's in the natural numbers. That means it's also contained in the whole numbers. It's also contained in these integers, and it's in the rational numbers. Anything in a smaller box has to be also in the bigger boxes. Okay? I'm going to get rid of that because that's a mess. So just looking at this list, anything that's a natural number is also going to be a whole number, it's also going to be an integer, and it's also going to be rational. These are all going to be real numbers. Let's write that down right away. They are all real numbers. I don't want to forget to write that, so I'm just going to write real for all of them. Alright, -9 is a decimal that stops. We have a 0.0, so it's definitely rational. It's also really just the number -9. That is a negative whole number or an integer. And negative numbers cannot be whole and they can't be natural. Those are just positive whole numbers. So that is all that is, just real, rational, and integer. This next one, we're going to do that division problem. That would give us 4.5. That's a decimal that stops, so it's also rational. This one had a decimal, but that's a 0.0. That really doesn't matter at all. This decimal does matter. That's a 0.5. That means it's not an integer. Doesn't have a whole number. It has a decimal. Can't be an integer. Next one's definitely real. When we take the square root of that, we should get a long decimal. Square root of 8 would give us 2.828427. Doesn't matter what goes on from there. It doesn't look like that's repeating. There's no repeating number there. And it's going to go on forever. That is an irrational number.